Okay, we're going to talk about conic sections with parametrics. First one we'll talk about is an ellipse. We learned in Algebra 2 that you had your Cartesian equation for an ellipse. So here's your Cartesian equation for an ellipse. The underneath the x minus h in parentheses squared is the x radius squared. Underneath the y minus k in parentheses squared is the y radius squared. So you have your, regardless of whether it's horizontal or vertical, the number underneath the x minus h in parentheses squared is the x radius squared. That's the distance from the center to the end point horizontally of the ellipse, and then the y minus k in parentheses squared, the y radius, is the distance from the center vertically to the end point of the ellipse. So when you talk about the parametric, you have your center is h comma k, and then you have your x radius and your y radius. Well, the parametric is x equals the x value. It's the x value of the center plus the x radius times cosine t, and y equals the y value of the center plus the y radius sine t. So that is the parametric for an ellipse. So basically, once you identify the center, you have your x radius and y radius, then you're able to plug it into the parametric equation. So basically that's all you have for an ellipse. Now the longest axis is the major axis. That's the number underneath, the number that's bigger underneath the x minus h squared or the y minus k parentheses squared. Whatever number is bigger, that tells you where your major axis is. Okay, now on an ellipse, we have you have the center point, which is h comma k, and then you have your ellipse that you draw. So if it's this way, we know it's horizontal. I apologize for what it looks like. I'm not an artist. Then you have your endpoints on that axis. Okay, so this is considered that's the major axis. Okay, this distance is the r sub y, and then here you have the minor axis. This distance is r sub y. Okay. Now, on the major axis, you have 2 points. Hopefully, you talked about in Algebra 2, but if you didn't, we'll talk about them now. You have 2 points on the major axis called focal points. The focal points are actually how the ellipse is drawn based off these 2 points. They are equidistant from the center, and the distance from the center to that point is c. The distance from the center of that point, the center to that point is c. And so there is a formula that we have on your formula chart to find the center. To find the distance c, and we'll talk about that in the next video I post. But I just wanted to touch base on that and tell you that the distance from the center to that point is c. Whether it's horizontal ellipse or whether it's a vertical ellipse. Now, when you have a hyperbola, you have your center point, and then on your center point, on your axis, which is no longer called the major axis, it's called the transverse axis, you have endpoints, and then there So if that's your conjugate axis, that's where the hyperbola is graphed. Then you also have what's called your transverse axis is where the hyperbola is graphed. Then you also have your conjugate axis, which has endpoints as well. And then from there, remember from algebra 2, you draw a dashed rectangular box or square box. And then the box is connected in through the corners by asymptotes. So we have two asymptotes there. And so the purpose of the box and the purpose of the asymptotes is to help me draw my graph. And then from there, I'm able to draw my hyperbola. Now also remember that your hyperbola also has focal points. The focal points are inside the hyperbolas there. Okay, so the distance from here to here is the x radius. The distance from here to here is the y radius. And the distance from here to here is c. That distance is c. So remember, the distance from the center to the focus point is c. The distance from the center horizontally is the x radius. The distance from the center vertically is the y radius. Okay, remember from algebra 2, you have your equation for a horizontal hyperbola. Remember, the difference between an ellipse equation and a hyperbolic equation is the fact that the two fractions are separated by a subtraction sign instead of a plus sign. If it's subtraction, it's a hyperbola. Now it's horizontal because the x minus h in parentheses squared fraction is positive, and then it would be a vertical hyperbola if the y minus k in parentheses squared fraction is positive. So the purple guy here is horizontal and the y guy here is vertical. How that translates to a parametric equation, if it's horizontal, then it's going to be x equals h plus the x radius times secant t, and y equals the k plus the y radius times tangent t. And the difference between horizontal and vertical is simply, it's the same setup, but secant will go with the x and tangent will go with secant will go with the y and tangent will go with the x, as it is here. X equals h plus the x radius times tangent t, and y equals k plus the y radius times secant t. So that is the parametric for a hyperbola. That's the parametric for hyperbola. So it's just a matter of making sure that you pick whether it's horizontal or vertical, and then it's just identifying where it goes there. Now the last conic section we're going to talk about is a parabola. A parabola also has a focal point, which actually is how we graph a parabola as well. So a parabola has a focal point. The distance from the vertex to the focal point. Okay, and each parabola has a focus and a directrix. So the focus and directrix, the directrix is a line that is perpendicular to the line of symmetry. And the distance from the focus to a point on the parabola and the directrix to a point on the parabola are the same. So for example, this point here, that distance, this distance is the same as this distance. Now it's not drawn. That is perpendicular to the line of symmetry. And the distance from the focus to a point on the parabola and the directrix to a point on the parabola are the same. So for example, this point here, that distance, this distance is the same as this distance. Now it's not drawn to scale, but they're the same distance. And that's how the parabola is drawn. And just that's in general. And we'll talk about how to switch from the either vertical parabola or horizontal parabola writing in parametric. Okay, so here we have the vertical parabola, y equals a times x minus h in parentheses squared plus k. And then we have a horizontal parabola, which is x equals a times y minus k in parentheses squared plus h. Remember, the vertex is h comma k. So for the y equals 1, it's like we've always done it. For the x equals 1, you want to be careful that you don't switch them because you'll get the problem wrong. If it's vertical, then my x equals is going to simply be h plus t. And my y equals is going to be k plus at squared. Remember, parametrics are with respect to time. That's why we use t. If it's my horizontal parabola, it's going to be x equals h plus at squared and y equals k plus t. So that is how you get your equation for the parametrics for a parabola. So this is just in general to get your equations for a parabola. Now, with that, this information, you should be able to complete the assignment that the kids got on Friday that weren't taking the English test for the parametric conic sections. I will post the answers on Edmodo in case you have any additional questions. I'm sorry I'm not in class today, but I will be in class tomorrow, and I'll post another tutorial for the other assignments you got today. Have a great day.